In this lesson, we are going to go over solving quadratic equations specifically related to application problems. So our goal is to solve application problems involving quadratic equations. I recommend having your calculator at the ready because we will be using it during our lesson. So let's get into our examples. So find the dimensions of a rectangular Persian rug whose perimeter is 20 feet and whose area is 24 square feet. You might be wondering where the quadratic equation comes into play, so let's get started on the problem. Whenever there is something I can visualize, I like to draw it out. So here's my rectangular rug. I'm sure a Persian rug is much prettier than what I am able to draw. And we are going to be talking about perimeter and area in this, okay? And when we're being asked to find the dimensions, usually we talk about the dimensions of a rectangle in terms of length and width. So we have width, length, length. Okay, so first let's deal with perimeter. The perimeter is when you add up all of the sides, okay, going around the outside, and we are given that that's 20 feet. So starting here at W, we have W plus L plus W plus L, and from the problem we're given that this is equal to 20. If we combine like terms on the left-hand side, we have 20W plus, not 20, I'm sorry, 2W plus 2L is equal to 20. So here's one equation that we'll be working with. The next thing that we're going to be dealing with is area. Now area is length times width, and it represents, if you were to break these into little boxes, okay, our area or the coverage of the rug or how much of your floor space it's going to take up. Okay, so area is given by length times width, and this is equal to 24. Okay, so we have two equations and two unknowns. So what we can do is we can solve for a variable in one of the equations, substitute it into the other, and you'll see where the quadratic equation comes into play. So what I'm going to do is from 2W plus 2L, I'm going to solve for L. You could solve for W, you could use the other equation. It really just depends on what you want to do. Okay, so again, I have 2L plus 2W is equal to 20. I'm solving for L, so I'm going to subtract 2W from both sides to get 2L is equal to negative 2W plus 20. To solve for L, we divide everything by 2, and we have L is equal to negative W plus 10. Now what I can do, remember I had a second equation, L times W is equal to 24. I can substitute what I found for L into this equation. Okay, so I have negative W plus 10, which is my L, times W is equal to 24. Okay, and now we distribute. So we have negative W squared plus 10W is equal to 24, and here is my quadratic equation. It appears in a problem similar to this. Okay, so now to solve, it doesn't look like the square root property, so I'm actually going to move everything over to the right to keep my W squared positive. Okay, so we add W squared, subtract 10W, and we have 0 is equal to W squared minus 10W plus 24. We look to see if it can factor, so we would be looking for two numbers that multiply to 24 and add to negative 10. So that would be negative 6 and negative 4. So we have W minus 4 times W minus 6 is equal to 0, and we get W is equal to 4, 6. Okay, so now let's go to the next slide to determine which one this is. Okay. We know that length times width is equal to 24. So that means scenario 1, if W is equal to 4, that means L is equal to 6. Or if W is equal to 6, so these are our two answers that we found on the previous slide, that means L would be equal to 4. Length is typically bigger than the width, so these would be our dimensions, 4 feet by 6 feet. Okay. Next example, my dog is on the couch 2 feet above the ground. She hears the doorbell and hops off the couch to assess the danger. So when she jumps in a curved fashion, or it's parabolic or part of a parabola. During her jump, her distance from the ground is given by the equation S equals negative 16t squared plus 0.5t plus 2, where t is in seconds. Sorry, the equation got moved a little bit. And there's a picture of my dog. Assessing the danger might be giving her too much credit. She's probably just excited that somebody is here. Okay, so first part, after how many seconds will she be 1 foot from the ground? Round your answer to 2 decimal places. So our equation here, so if you can picture my cute little dog, which is on the screen, she's jumping off the couch and she's going like this, okay? So this is 2 feet. This is the ground. And we want to know after how many seconds, so this is starting at 0 seconds, after how many seconds will she be 1 foot off the ground? So let's say 1 foot is about here, okay? So what this is telling us is that we need to say that S is equal to 1. Remember, her distance from the ground is given by S equals, okay, S is our distance from the ground, T is in seconds, S is going to be in feet. So what we do is we plug in 1 for S, and then we solve. So we're looking at, and I'm going to go to the next slide, negative 16t squared plus 0.5t plus 2 is equal to 1. Oh, look, we have a quadratic equation. Okay, probably not the square root property. I'm going to move the 1 to the other side. So I have negative 16t squared plus 0.5t plus 1 is equal to 0. This is probably not going to factor even by the x method or the AC method. And so I'm going to jump right into the quadratic formula where a is equal to negative 16, b is equal to 0.5, and c is equal to 1. So we start off by plugging everything in. We have t is equal to negative 0.5 plus or minus the square root of negative 16 squared minus 4 times a times c all over 2 times negative 16. Okay, and then we continue on from here. T is equal to negative 0.5 plus or minus the square root. Negative 16 squared is 256. Then this becomes plus 68 over negative 32. So now I have T is equal to negative 0.5 plus or minus the square root of 320. Let me see. That's not right. It's not 320. Let me look. 324 all over negative 32. Okay, so now since we're probably going to be using our calculator for this given the numbers, I'm going to find our 2 solutions for t. So first we have t is equal to negative 0.5 plus the square root of 324 over negative 32. And I also have t is equal to negative 0.5 minus the square root of 324 over negative 32. So let's find both of these values and determine what our answer is. So remember, when you're plugging in negative 0.5 plus square root of 324, if you're using a calculator like this, your numerator needs to be in parentheses, or you put in the numerator, press enter, and then divide this by negative 32. Okay, so we get negative, and we're going to 2 decimal places as needed, so this would be negative 0.55 seconds. If you're wondering if seconds can be negative, hold that thought. Okay, and for the bottom one, this one I get 0.58 seconds. And we need to go backwards for a minute. I'm going to write this in red. This is supposed to be 64, so this would have been 320. Okay, so make sure you fix that in your notes, or maybe you caught the mistake. And so I'm going to cross these out, and I'm going to redo each value. So let's go to the next slide. We have t is equal to negative 0.5 plus the square root of 320 over negative 32. And t is equal to negative 0.5 minus the square root of 320 over negative 32. Okay, so now let's see what we get. Plus square root of 320 divided by negative 32. So to 2 decimal places, this would be negative 0.54. And this would be 0.57. Time cannot be negative. We're starting off at t equals 0. So for this first part, after 0.57 seconds, she would be 1 foot from the ground from her 2 feet high jump originally. Okay. Next, how long will it take her to reach the ground? Round your answer to 2 decimal places. Again, a visual. As she's jumping, here's where she reaches the ground. Remember, S is distance from the ground. So when you're reaching the ground, that means s is equal to 0. Okay, so what we do with our equation is we set s equal to 0. So we have negative 16t squared plus 0.5t plus 2 is equal to 0. And we'll use the quadratic formula once again. So we have x is equal to negative 0.5 plus or minus the square root of negative 16 squared minus 4 times negative 16 times 2 all over 2 times negative 16. Okay, so I'm gonna simplify what's under the square root and do the operation 2 times negative 16. So, and this should be t equals, okay, because we're working with t instead of x. So we have t is equal to negative 0.5 plus or minus. This becomes 256 plus 128 divided by negative 32, which is negative 0.5 plus or minus the square root of 384 over negative 32. Okay, so now I have two answers, negative 0.5 plus the square root of 384 over negative 32, and I have negative 0.5 minus the square root of 384 over negative 32. So we'll plug both of these into the calculator. And for the first one, this becomes negative 0.60, and for the second one, this is 0.63. Okay, so again, we'll take the positive one because that's what makes sense in our context. So in less than a second, she'll reach the ground and she can continue her run onto the door. The last example we'll go over is using a triangle. We'll use the Pythagorean theorem to find the lengths of the sides of the triangle. The Pythagorean theorem says the leg squared plus the leg squared is equal to the hypotenuse squared, or if these are a, b, c, a squared plus b squared is equal to c squared. So what we'll do is we'll square each of the legs. We'll set that equal to the hypotenuse squared. Since we're squaring things, we're going to end up with a quadratic, and then we'll be able to solve for m. Okay, so a squared is 3m squared, b squared, and that's equal to 5m squared. Now I'm putting these in parentheses because we're squaring the entire thing. We're squaring the entire leg, which means 3m times 3m, or 2m plus 18 times 2m plus 18. Okay, and same with the 5m. So this is 9m squared. This becomes 2m plus 18 times 2m plus 18, and that would be 25m squared. Okay, so use FOIL for 2m plus 18 times 2m plus 18. This is 9m squared plus 4m squared. 2m times 18 plus another 2m times 18 is going to give us 72m. 18 squared is 324, and this is equal to 25m squared. Okay, so I'm going to take everything now that's on the left-hand side and move it to the right, just to keep my m squared term positive. So we'll subtract, this is 13m squared plus 72m plus 324 is equal to 25m squared. So everything will subtract the 13m squared, the 72m, and the 324. Okay, so what that looks like then is 25 minus 13m squared minus 72m minus 324 is equal to 0. And we continue to combine our like terms to get 12m squared minus 72m minus 324 is equal to 0. Now when we're factoring, we always look for a greatest common factor first. I know that 12 and 72 are divisible by 12, so I'm going to see if 324 is as well, because that means 12 would be my greatest common factor, and it is. So it's like we can divide each of these by 12. And now we're just worried about factoring the m squared minus 6m minus 27. We are looking for two numbers that multiply to negative 27 and add to negative 6. So that's negative 9 and 3. So we have 12, m minus 9, m plus 3 is equal to 0. So this gives us m equal to 9 and negative 3. We don't have to do anything with this 12 because it's just a number. You could technically divide it on both sides and it would cancel out. Now we have to choose which one it is. So remember that we were given, this was 3m, 5m, and 2m plus 18. The sides of the triangle are going to be positive, which means that we'll take m is equal to 9. Okay, so the last thing you have to do is substitute m equal to 9 into all of these. So we'll do that on the next slide. So we have 3m, 2m plus 18, and then we have 5m. Okay, so remember we just found that m is equal to 9. So 3 times 9, this leg is 27. 2 times 9 plus 18. That is 18 plus 18, so this side is 36. And 5 times 9 is 45. Okay, so depending on what the question is asking for, you can answer it either with the 2 legs or with the hypotenuse. Thank you for watching. If you have any questions, please feel free to reach out to me.